It is said that the factory of the future will have 2 employees.
Voice controlled, or where they'll instantly hook up with other devices in the home, and it's just seamless.
We won't have to do anything. We'll have machines that do our jobs.
It's the application of technology to solve problems in an imaginative and innovative way.
Ways that are helpful to organisations.
It's crazy not to build something that would save you money and save the environment in the long run.
The Internet of Things has a parallel with the early days of the Internet. The early days of the Internet was all about generating data, capturing that data, cleansing that data, augmenting that data, and then extracting value from that data. And the early days of the Internet grew from that, and we saw the explosion in the protocols and the products to facilitate that to what we now have today. And if you think about the Internet of Things, as we now call it, it's almost like the early days of the Internet. It's about generating data. It's about moving that data, capturing that data, cleansing that data, augmenting that data, deriving value from that data, servitizing that data. That's where we are. And there's a huge set of consortium and conflicting views as to how that will actually emerge.
The next industrial revolution is here, and the Internet of Things is playing a pivotal role. From hospitals to factories, or even around the house, technology is delivering an interconnected world where science fiction is becoming a reality.
It's really a bringing together of networking, sensors, computer systems, many things that could probably be done without that interconnection, but the availability of interconnection and the way that it's becoming much more easy to connect consumer devices, computers, networking and so on together just makes the whole concept more implementable, more easy to achieve.
Sensor technology has been around for a long time, and that's what underpins the whole of the Internet of Things. And in fact, I think it was a French physicist in the 1830s who developed the first sensor with the ability to respond to light. And over many years, all manner of analog sensors have been developed. And then in the 1970s, we saw the development of the digital sensor.
Yeah, there were several steps in the evolvement of what's nowadays called the Internet of Things. Originally, these were sensor networks which were not necessarily internet enabled, which just had local communication with each other.
But what we've seen post that time is this assemblance of technologies to come together and capabilities to give us the marketplace which we now see.
The bigger availability of network, especially regarding mobile phone networks, which were then internet enabled with the expansion of mobile phone networks, one was able to use the internet capability for this. Systems there, plus also the sensors themselves using MEMS devices there, which could sense various things.
They have the ability to detect the temperature, the humidity of the environment. They can detect the presence of magnetic fields.
Whole miniaturization of devices and sensors has contributed a lot, and there is still progress to be expected.
There are various platforms available to you in which you can actually build a little IoT platform. So you can, Arduino is well known, it's loved by the hobbyist community. It's a very simple board, but it has great extensibility, very simple to program, and you can attach your sensor to that. And they will, out of the box, begin to capture environmental information. So it might be, for example, something as simple as a temperature. You may have a smartphone. You can then actually program it to structure those ones and noughts, that temperature information which has come from that sensor. And then you can then push it on into, for example, an open broker. In the internet, as you have this huge broker which is sat there taking all of this data in, and you can register with that for particular topics. So you could go to the broker and you say, well, actually, I'm interested in a topic called Fred 123. And what the sensor does is it generates the data, it comes to the phone, you then package it up, and you say the topic of this piece of data is Fred 123, and then you push it into the internet. So you're going from Bluetooth low energy to standard Wi-Fi to standard TCP/IP protocols, and it goes to that broker. And at the broker, it sits there. And if you're registered, listening for Fred123, then that message is then passed to you, and then you can then consume that data. You can actually go now to these sensor tag manufacturers and say, well, actually I want it to do A, B, C, D and E, and I want it in this form package, and I want to be able to hide it away in this environment for, let's say, 1 year or 2 years. But we're now seeing with sensor tags the ability to what's called energy harvest. They have the capability to take energy from the light, they have the ability to take energy from motion, for example. And now we've just seen developments where they can actually transmit power at something like 1.
It is said that the factory of the future will have 2 employees, a man and a dog. The man will be there to feed the dog, and the dog will be there to make sure that the man doesn't touch any of the machines.
It's very simple.
Sensor technology is available to the general public as well as developers. The Internet of Things is increasing industrial production and efficiency with multifunction sensors and is set to contribute $7.1 trillion to the global economy by 2020.
Well, if you can better understand the condition of things, you can track and monitor, you know when you're going to need to maintain them. You don't waste money, you don't waste resource in doing that.
IT is used increasingly to improve our weather predictions, to improve our flood warning systems, and to improve our management of natural resources.
It can really help us identify if someone's going to have a disease of some sort, how it can be treated.
Internet of Things is related in healthcare for care of elderly, where, for example, people wear sensors and can be monitored who are not able to completely care for themselves and who have to be monitored so that one can detect dangerous situations.
Niche use of IT, such as GPS systems, traffic systems which I've been working with in DEFRA around smart cows, giving them a necklace that they wear and that determines the health, their temperature, which farmers can use to detect whether their animal is sick, well as its position.
The potential benefits of the Internet of Things are many, but all technologies come with costs and barriers attached.
One of the biggest challenges that we see going forwards is going to be in the communication of the terabytes, the petabytes of data that we will be generating.
I think if you're buying into the strategy, you need to go in with your eyes open. I think it's important you think about the architecture of whatever solution you're going to put in place. I think you have to think about the currency and the relevance to the environment in which you're bringing it.
We have to be looking at retrospectively applying smart technology and thinking. And then I think it's saying, there isn't any kind of panacea. You need to look at easy to implement technologies, stuff that's relatively low cost.
And you must keep an open mind at all times to what we call the non-functional requirements, and security is very much a part of that.
There are certainly issues regarding IoT and data security, because these systems collect data and then they are often not connected with a wired secure connection, but through wireless RF transmission, and it is in principle possible to capture or try to capture data, and then it has to be made sure that these data are protected. And so this is a big issue there, in which a lot of research is going on at the moment to make those data secure.
I think there is a view permeating at the moment that something in the order of between 7 and 9% of budgets are being redirected towards the Internet of Things. Do bear in mind that the Internet of Things is now becoming a broad church, so it might not necessarily be, for example, thinking about sensor technology. It may be the analytics side of big data which is being generated.
Even just to install sort of networking and the general kind of systems like that can be challenging in older buildings. So to actually take it a step further and go through the sort of Internet of Things, full connectivity, eco-building is again a much bigger challenge.
Clearly a lot of our housing stock, our building stock, our infrastructure across transport and so on has been around for quite some time, and that's not going to shift instantly overnight. There are big initiatives to improve that, but clearly it's not all going to change. So you don't have to sort of completely revamp a building, but you can apply some low-cost sensors, you can have some communication technologies that will hook things up without having to put in lots of wires and so on. And then you can apply analytics and thinking on top of that. So it can be quite light touch, and I think you can do it in an incremental sort of piece by piece way, regardless of what infrastructure you've got on the ground.
The Internet of Things requires energy, but its sensors may lead to savings in energy used as well as capital spent.
The thing about the Internet of Things is that we have the internet, and now we have the Internet of everything. So we have another world which is developing, another world which is consuming resource, whether it's precious materials and minerals to actually compose these things which we wear or which we see on a day-to-day basis or which are used in factories. But they're all consuming a resource and they're consuming energy.
Clearly we face challenges going forward with climate change and seeing what we can do to continue to reduce the impacts of the IT we use, to improve the efficiency of that IT, and in return get IT to do more and more in our lives to help us live more sustainably and use less energy, less travel, less resources.
Canary Wharf Group are doing some really fantastic stuff around introducing smart technologies, looking at what that can mean in terms of the efficiency of their buildings, across things like lighting and heating and so on.
We reckon we could save around about 10%. That's based on some modelling that one of my colleagues has done in terms of energy use within the buildings, and around about a 10% saving in the university's electricity bill would be possible if we were to implement that across the whole of the campus.
If we look at environmental considerations to do with the Internet of Things, then one additional thing that's really topical at the moment is air quality. We see that being increasingly sort of quite a big political issue and a genuine one for people in terms of things like the number of premature deaths or the impacts that it has on people's quality of life and health. And that we're increasingly able to look at more precisely because we can monitor that, we can look at what that means. But then it's more interesting if you say, well, how could I combine different sets of information? How could I look at air quality versus health? How could I relate that to real-time transport decisions?
You can do things like control traffic flows, manage traffic systems much more efficiently and more effectively.
Like nuclear disasters where they've occurred, we'll have readings and things so that we can prevent things happening, we can see what might be happening, how we've dealt with it.
In the first instance, simply being able to monitor things more precisely to understand how they're performing and what you can do about it, but then to be able to take corrective measures. So again, the more you look at that and you're able to analyse and track in real time and understand the impacts, the better you are able to act.
There are periods when it makes sense to supply from a wind source, where there are times when it makes sense to supply from a solar source. We can look at the current demand, we can look at the predicted future demand, we can be intelligent about the way that we switch around between our different energy sources.
The direction of travel of the Internet of Things is also towards automated actuation in the sense that you can control devices within buildings and do things in real time to make them more efficient.
Now we have to be mindful as we go forward as to our energy and carbon footprint. We only have one planet and we have to use the resources which we have in a sustainable manner.
So it's very much part of trying to live within a world of constrained resources where increasingly we need 2 or 3 planets to actually sustain the population that we now have as it grows.
So my fear is that we could actually exacerbate the problem, but my hope is that the Internet of Things may actually improve the energy and carbon profile of the systems which we use today.
The infrastructure of the Internet of Things may decrease our carbon footprint, reducing phantom energy loads by powering and heating our homes only when really needed.
I think it is the future of new build housing. I think we should all be building that way. It's crazy not to build something that would save you money and save the environment in the long run. But I think there's a lot more that needs to be done. And we all have a responsibility to do our bit in terms of saving energy. Another important factor of getting people to reduce their energy is knowledge and knowing how much energy you're using in the first place. So what we did was we developed a digital system for our houses where people can control and monitor their house from their smartphone or on the internet through the laptop. What it enables you to do is to see exactly what you're using in terms of your electricity, your water, and also to control your home from your phone. So we have a home and away switch which can turn off all the non-essential sockets just at the flick of a switch. That makes it so much easier for people then, rather than running back up the stairs to turn off your light if you're in a hurry. So we're trying to design things and use technology to help people reduce their impact on the environment.
It would be very beneficial if there were extra kind of policy tax incentives through provided by government to actually make that happen more effectively. I think the potential is there, the opportunity is there. It does, I think, surprise me a little bit that that it isn't mandatory, for example, for new homes to have solar panels fitted.
So we'd like to see a lot more companies do it. There is, of course, some companies doing it, but there needs to be a lot more to deliver the housing that we need in the UK over the sort of coming years.
Data generated from your house can help you save money. Data stored across the Internet of Things might save the world, but whose data is it?
So somehow you've got to understand this data that's streaming around, whether it's data at motion or data at rest. And in understanding that, you've got to be able to append that to a use case for people to get value from it. But who's managing all of this? Who is it?
Joining up data is a clear challenge we face. We talk about data as if it's some sort of benign, readily understandable collection of digits. But of course it isn't. It needs interpretation. So I think it's quite important that data definitions, the semantics behind data, the modelling of data is taken on board at the same time.
Who owns the data? In a closed environment where, for example, let's say you're a manufacturer and you're taking a whole series of parts and you're assembling a product, and that product is then used by some other third party. In those closed environments, you own that data. But you're also, in owning that data, you're responsible for securing that data and for the maintenance of that data. Where the challenge is, of course, is when the data becomes public, when little data becomes big data. In fact, the privacy of little data is probably just as important as the privacy of big data. But we have the Data Protection Act, and there's various pieces of legislation which have been enacted by the European Union to protect the data which you generate, even though you may have actually transferred ownership of that data to some other third party. So there are many challenges ahead of us in terms of the authenticity of that data, but also securing that data, not only for the data for today, but also that data as over time. And that's interesting, I think, in terms of the challenges perhaps which blockchain technologies now present to us.
Machine-to-machine decisions will increase from 22% to 35% in 2020. Protocols exist, but data is valuable.
Well, as we've already seen, all the problems that we've got with the internet, which people have found we can no longer police, and there's always a darker side. Every time there's a new invention, a new idea, some innovation, some new technology, there will be a dark side to that technology. And unfortunately, that will always be the way. So really what we need to look out for is how much are we going to benefit from this in the long term. I think people need to be made aware of the long-term issues and really where we're going. It seems like utopia at the moment, but I'm not quite sure what we have to pay in order to get there. People haven't made that connection, that we do have that physical, but it is into digital, and so they don't always understand what that means in real terms with regards to privacy.
There have been especially cases when vehicles, for example, cars nowadays also considered internet-enabled devices, when somebody breaks in them and disables suddenly their security features or takes over the car remotely. And there have been quite some gaps, and the manufacturers of these devices.
The idea of security versus privacy versus availability is one of those big ethical challenges that where the provision of information appears to be voluntary, your Facebook details and so on, people seem a little bit easier about making that information available. When they get the feeling that somebody else is collecting that data, it makes it different. It changes the rules a little bit.
The opting out option is, we're told it's always there, but in practice I'm not quite sure.
There is always that period of reluctance. There's always that period of not wishing to become involved. I guess everybody's done it at some point with some piece of technology.
You are, for example, walking around a supermarket or walking around a high street, and the devices which you have are streaming data, or by your mere presence being there, I know you are there, I'm deriving some value from that. Are you engaged in that? Probably not. And that is a concerning aspect to all of this. And it's the security and the privacy of the data, not only today, but in 10, 20, 30 years' time, of what you were doing at that moment in time. Somebody has to oversee that.
Who will govern? That's the big question. Since the internet anyway, that's been one of the major questions. I don't know who's going to be able to govern any of this. We really need to have some sort of strategies and policies in place with regards to the technology.
Linked up to the Internet of Things, technologies are already altering the urban environment. 4 UK cities are at the forefront of smart city technology.
So a smart city is often thought of just in terms of the technology that's applied to it. And technology is really important, but it's the application of technology to solve problems in an imaginative and innovative way. And very importantly, it needs to lead to improved outcomes for both citizens and for businesses and for the city authorities themselves. It's been helped by the fact that the government has had various different initiatives, some of which are driven by Innovate UK, which are about stimulating that investment, competitions and sort of different things that encourage people to begin to invest and to drive forward programs and projects. Manchester clearly is a winner of the recent IoT Smart Cities competition. You look at Bristol being really innovative around citizen engagement. MK Smarts, Milton Keynes are doing some fantastic stuff, looking across transport, parking, waste, all manner of different things. So you're starting to see some real big scale stuff happening and some really exciting things happening, including here in London. So one of those examples is in Old Oaken Park Royal. This is the largest regeneration project right across the UK and one of the largest in Europe that's happening right now. And we've been working through Hypercat to create their smart strategy so that they can be smart right from the start. And that means that they can think about how they want to blend together different technologies across utilities and transport and waste and so on, right across the piece. Think about how those are going to be planned and scoped, implemented and then run, make all of that smart. Whereas in the past, a lot of that has been applied as a kind of afterthought to existing cities and existing environments. This is a great opportunity to do that right from the beginning. So that's a really good example of where smart is happening at scale in the UK.
In the revolution that is the Internet of Things, each year brings new development. Moore's Law has laid out the pace of physical development of computing for decades. The Internet of Things is bound to bring about changes in all our lives that are just as dramatic. Changes are likely to happen faster than we think.
In 1990, there was as many sensors on the planet as there were human beings. By 2020, there will be something in the order of 75 billion sensors connected to the internet. And if you think that the human mind has something like 83 billion neurons, you're almost at the point now where there is many of these sensors attached to the internet as there are actually neurons in the human mind.
Pure widespread of this technology will show new possibilities of interacting with data, that our daily life will have so many different devices. And one of the factors for enabling that is also the new Internet version 6, which allows more devices than actually there are atoms in the universe.
Traffic flows, traffic lights, traffic direction, traffic routes and so on are much more closely controlled and much more responsive to current situations. But shops to push out adverts to you as you're walking past saying drop in and buy whatever it is we're selling at a lower price than the shop next door.
Internet of Things could actually sense if you're at home or have your intention of going home, and could know that you're at work now and you're about to go home, and then switch on the heating when actually needed.
Understanding when the crops need to be planted, when the crops need to be watered, when the crops are ready to be harvested.
To actually produce a more efficient use of existing resources. And that's where I think will be a lot of positive applications of this technology.
Our whole way of being, our whole way of behaving will change in accordance with our environment. We know behaviour has changed already with the introduction of technology, and with this advancement with the Internet of Things, it's going to exponentially change again. So we will have to adapt to our utopia.
What comes after the Internet of Things is, I think, one of those what happens next questions. Certainly wearable computing, the things that will allow us to have computer devices much more embedded within the things that we do. Virtual reality devices that actually work and are actually usable for more than a few minutes without completely affecting your balance or your eyesight or whatever. I think those kind of technologies are somewhere just on the horizon.
So we're going to have huge amounts of data, but there's no value in data. There's value in knowledge. And so we've got to be able to convert data into information, into knowledge, to extract value from it. And how we do that is where the developments are going to come.